Hi, welcome to the neighborhood. As you know, my series is called Permu's Patio. I spend my time here on my friend Permu's balcony. Permu has flowers and likes to rearrange them. Another section of what we talked about was on permutations and combinations. So at some point you may be interested in watching that as well. But Permu's problem today is she loves to cultivate potted plants, but she's got plants that have developed a problem with square roots. And so she's asked me to find a way to help her simplify these square roots so she can get the plants out of the ground easier to repot them and the like. This will be a 4-section discussion on square roots. It's in 4 separate parts because there are some fundamental skills we need to brush up on before we do simplifying of square roots. The first section is divisibility. And that's what we'll be doing right now. The second one will be on short division, the third one on prime factoring, and the fourth one on simplifying square roots. And I hope you won't necessarily skip right to the last section because you think at this point that you know prime factoring or you know short division. They'll all be useful as a short review. So today we're going to be talking about whether these numbers, 2, 3, 5, and 11, can be divided into other numbers. You'll probably recognize these as 4 of the first prime numbers. We're missing 7. And we're also missing 4, 6, 8, and 9. Well, why are those missing? Well, we don't need 4 because 2 goes into 4. And we don't need 6 because 2 and 3 both go into 6. And we don't need 8 because 2 goes into 8. 7, unfortunately, has no good rule. We'll just have to be good at working things out for ourselves on that one. But just in general, and for most of the problems that you're liable to have to simplify in an SAT or other environments like that, you really won't need to be able to divide by more than 2, 3, or 5. So let's start off. The number 2, this is a rule that you probably know from elementary school. If it's an even number, the number 2 goes into it. So for example, 42. Even numbers end in 2, 4, 6, 8, or 0. 42 ends in 2, so 2 will go into 42. How about 45? Well, 5 is not an even number, so 2 will not go into 45. How about 1,287,422? Well, 2 is an even number, so this whole thing is an even number, and 2 will divide into that number. How about 3? 3 is a little mysterious. For 3, we care about the sum of the digits. So, for example, 27. Well, I know 3 goes into 27, it goes 9 times. But just from the standpoint of the rule, 2 plus 7 is 9. So 3 goes into 27. How about something a little tougher? How about 423? Can we figure out very quickly if 3 goes into that number? Well, 4 plus 2 is 6, plus 3 is 9. So 3 goes into 9, and 3 goes into 423. How about 629? Well, 6 plus 2 is 8, plus 9 is 17. 3 does not go into 17, so 3 does not go into 629. Why don't you take a moment here, stop the video, see if you can find 3 other numbers that have at least 3 digits that 3 will go into. Okay, great to have you back. Why don't we try a really big one? 1, 2, 8, 7, 9, 2. Let's see about this one. 1 plus 2 is 3, plus 8 is 11, plus 7 is 18, plus 9 is 27, plus 2 is 29. 3 does not go into 29, so 3 does not go into this number. But could I add a digit over here that would give me a number that 3 would go into? Well, let's try again. 3, 11, 18, 27, 29, 30. 3 would go into this number because the sum of the digits is 30. How about 5? 5 is another one you've probably known since elementary school because you could count by 5s. 5, 10, 15, 20, 25, 30. If the last digit, and remember, each of these numbers is a digit. If the last digit is 5 or 0, then 5 will go into that number. So 225, for example, ends in 5, 5 goes into that number. 4, 9, 8, 7, 2, 3, 5, 0. Ends in 0, 5 goes into this whole number. How about our last one, 11? Well, if it's 2 digits, it's something you've known since elementary school. 11, 22, 33, 44, 55, 66, and so on. So if it's 2 digits doubled, for example, 22 or 88, then 11 goes into those. But where it's more interesting, if there's 3 digits, let's look at the middle digit. For example, 143. You notice anything interesting about the middle digit relative to the other 2? The ones on the end? Well, take a look at 1 plus 3. 1 plus 3 is 4, and that's the same as the middle digit. That's really the rule for 11. If these 2 end digits add up to the middle digit, then 11 does go into that number. How about 275? Well, 2 plus 5 is 7. That's the same as the middle digit. 275, 11 goes into 275. You can pause for a moment and verify that for yourself. Okay, let's see if we can make numbers that 11 goes into. This is kind of fun, actually. Let's try 37 for our first 2 digits, and then tell me what this third digit is going to be so that 11 will go into it. Well, I need these 2 digits to add up into 7, so take a second here and see if you can figure out what this last digit will be. Right, it's going to be 4, because 3 plus 4 is 7, so 11 goes into 374. Chances are when we're doing our prime factoring, we won't get to an 11. But if we do, it's a very interesting rule, and it works for all numbers, believe it or not. Although if I want to go beyond 3, and in some cases even 3 digits, I need to think about something else to be sure that I understand what's going on. But most of the time I'll be able to look at it and tell right away whether 11 goes into it or not. So that's the end of our divisibility. At this point you should be able to tell whether 2 goes into a number, 3 goes into a number by adding the digits and seeing if 3 goes into the total, whether 5 goes into a number by the number ending in 5 or 0, and whether 11 goes into a number by looking at the first and last digit compared to the middle. Thanks a lot, and I'll see you back in the neighborhood next time.